Hi everyone, this video is showing you how to use the website Geogebra to make reflections, rotations, and glide reflections and translations. The first thing you want to do is make sure that you're at the right website. So the one that I'm using is geogebra.org /geometry. So make sure you have that /geometry there, and you'll have all the same tools that I've got here. If you're not already there, you want to select Tools and hit More, and that should give you all the tools that you need, but if you see anything here that may have changed, it may be under this More menu here. So the first thing I want to do is show you how to do a reflection. So I'm going to start by reflecting a polygon. So I've made a polygon here. And let's say that I want to reflect this such that A is mirrored over here on this point D. So A is going to line up with D. The way that I make a line of reflection, if it's not given to you, is to look at the perpendicular bisector of these 2 points. So if you think about where that line of reflection might be, it's actually going to be halfway in between this point and this point, and it's also going to be perpendicular to the line connecting them. So if I select the perpendicular bisector tool, then that's going to make a line of reflection. Now I can go down to my transform, and if I select reflect about a line, the hint tells me that I should select the object to reflect and then the line of reflection. So I'm going to select the object somewhere inside the polygon here, and then the line of reflection, and that'll give me my reflected image on there. You can also do this with just a point, right? If you wanted to just reflect a point, you would select just that point there in the same way. Okay, next up is a rotation. So I'll start off by showing you a polygon and what that means when you're, for example, given a rotation arrow. A rotation arrow is something you can give in place of an actual angle. So I know I could rotate this 90 degrees clockwise, but I could also, instead of saying 90 degrees clockwise, I could give you a rotation arrow. So let's say that I've got D, E, F here. So I'll add some instructions here. Let's say you are asked to rotate the triangle according to the rotation arrow DFE. So I'm going to use not in order there, DFE. So what this means is I've got this angle DFE. F is going to be the center point of my rotation. So if you picture a wheel that starts at F, all right, and I'll just connect it with one of these points here. This object should be rotating along this wheel here, all right? So F, whatever's in the center here in your rotation arrow, that's the middle of it. Now, when you go to rotate around a point, you're going to select the object. So that's going to be this triangle. You're going to need to know the center point, and then we're going to need to know the angle. So if you try to start rotating this, you'll see that it gives you a prompt to see where the angle is, right, or what the angle is. We don't know that yet. So what we're going to do is just quickly measure that angle DFE. So I'm going to take this and make sure you're doing the correct order, right? D, F, E. So I'm using this measure angle tool to say D, F, E. And if I temporarily hide this point here, if I don't show the label for just a second on F, we can see that the angle there is 41.5 degrees. Now, we know the angle is 41.5 degrees, but the other thing we need to know is whether that's clockwise or counterclockwise rotation. So the way that you can think about this is you can think of F is definitely the center here, but you can think of this as being a clock, right? And the order here matters, so DFE means we're moving from D to E. And I would say if these clock hands are moving from D to E, that is definitely a clockwise motion, right? So from DFE, the rotation arrow DFE is telling us we're rotating 41.5 degrees clockwise. On the other hand, if you had something like EFD, so if this was written out EFD, then this would be E to D. So this line EF to FD, that would be a counterclockwise motion. So anyway, we know now that DFE is our clockwise motion, so we're going to rotate this triangle around this center point, F, and we're going to rotate it 41.5 degrees clockwise. So select the object, select the center, and this is going to be 41.5 degrees. So we'll rotate that clockwise. And then we get the image here that we wanted, right? This is our triangle rotated 41.5 degrees. Okay, so that's how you do rotations. The glide reflection, I'll do translations very quickly here. So translations are pretty straightforward. Let's say that you are given the problem where you say translate the given triangle according to the slide arrow ED. Right? So what that means is each of these points on the triangle A, B, and C are all going to be moved this far, right? This distance from E to D. But it is important to notice the direction of this. So our starting point should be E, and our end point should be D, meaning that if we move from E to D, that we're sort of taking all these points and we're moving them down and to the left here, right? So when you hit translate by vector, it says select the object to translate and then the vector. That's what we want here. So I'm going to select the triangle, and then my vector, I can either select this, but that's a little ambiguous, right? We want to say from E to D. And you even notice here, maybe if I zoom out a little bit, actually I'm just going to hide that label for just a second. You can see that it has the arrowhead in the correct direction here, right? From E to D. So that's translation. The last one that you'll need to know how to do is a glide reflection. And this is one that I didn't cover as well as I would have liked to in class. So I'll give an example of this. Let's say we want to use glide reflection to on the point P, where we use the the slide arrow BA, and the line of reflection touches C. Okay. So when they give you these points, they'll give you some coordinates. I'm just going to pick some random points, and then I like to just label this. Right. I like to label this P just to help keep things in order. So P is going to be a thing that's moving around here. And if you look at your notes, it says that glide reflection is either a translation plus a reflection, or a reflection and then a translation. But the thing that I didn't mention that is going to be important for this problem is this following rule that we have. So it's a restriction. If you're not given a line of reflection, what we're saying here is that so this is the rule. The line of reflection, spell that right, is parallel to the slide arrow. Right? Right, so that's going to be an important property that we have here. Okay, so we've got a slide arrow from B to A. I'm going to do the translation first, and then I'm going to do the reflection. The first thing I want to do is, starting at B and going to A, I'm going to take my point and translate it according to that slide arrow. So I select the point just like we did with the translation. The arrow is BA. So that gives me this point over here, P prime. And then the next thing I want to do is reflect it along a line of reflection that touches C. Now, the way that we did reflections before was we kind of made these perpendicular lines. At first glance, it may seem like P double prime would need to be over here. That image would need to be reflected over here. But the restriction that we put when we just have a point that touches the line of reflection, it's going to be the same as, it's going to be parallel to this slide arrow here. So there's a couple different ways to do this. I think the easiest way is to just use this parallel line tool. So that says select a point and a parallel line. Here's my point that's on the line of reflection, and then that's got to be parallel to the slide arrow. The last step here, we've already translated it according to the slide arrow, BA. Now we just need to reflect it across our line of reflection that we made. So that'll be under transform, reflect about a line. Take this new one, right, the one that's already been translated, and reflect that along lines. That is going to be our point, right? That's going to be our glide reflection of P according to this arrow across a line of reflection that touches C. So this P double prime, that's our final answer for this. All right, I hope that was helpful, and I will see you in class.